Imaginary roots and complex conjugates. Learning target. I can solve for roots of a polynomial. I can solve for roots of a polynomial. What do we call non-real roots of a function? They are imaginary roots. They always come in pairs. For example, and if you're wondering why, if x squared plus 4 equals 0, in order to solve for x for my roots, I'd have to subtract 4 from both sides. I get x squared equals -4. When I take the square root of something, I get the plus or minus answer. So there's my 2 answers that I get. And then the square root of -4 gives me 2i. So there's my 2 imaginary roots. So they always come in pairs. Find the roots of the function. In order to find the roots of the function, remember you need to set each factor equal to 0. All right, so let's do that. Set these factors equal to 0. X minus 3 equals 0, and x plus 5 equals 0. If I'm solving for my roots, I'm going to add 3 to both sides. I get x equals 3 as one of my roots or my x-intercepts. Again, continuing, I'm going to subtract 5 from both sides, and I'm going to get x equals -5 as another root of my polynomial. This makes sense because we have a quadratic, a degree of 2, 1x, and my second x gives me a degree of 2, which means I have 2 possible roots. Move on to the next one. If I am solving for my factors, my roots, I set each of my factors equal to 0. Add 25 to both sides. X squared equals 25. I don't have x alone yet. I need to take the square root of both sides, so I'm going to get x equals plus or minus 5. Finishing off with my factors, add 3 to both sides. I'm going to get x equals 3. Well, let's see here. How many roots should I have gotten? I have 1x and 2x here because that x squared is telling me I've got 2 x's. And then this x right here is telling me that I have another x. So I have 1, 2, 3 x's, which means I have 3 possible roots. So I've got 1, 2, 3 roots. All right, move on to our next one. Let's set these equal to 0. X squared plus 25 equals 0. X minus 3 equals 0. X plus 7 equals 0. Solve for x on both sides. Subtract 25. X squared equals -25. When I take the square root of both sides, x equals plus or minus. Well, the square root of -25 is going to be 5i. So I have 2 roots right there. Those are my imaginaries. I got plus or minus 5i. Add 3 to both sides. I get x equals 3. And my last one, subtract 7 from both sides. I get x equals -7. Again, this makes sense because I have an x squared, which tells me I'm going to have 2 roots, an x and an x. So I've got 2 roots, 3 roots, and 4 roots. I've got 1, 2, 3, 4 roots. So these make sense. My next one, I've got x minus 9 equals 0. And what this tells me right here, this squared is saying x minus 3 times x minus 3. So we would rewrite this as x minus 3 times x minus 3. Setting each of our factors equal to 0, we would get this. It's important to note that if we're squared like this, it's going to cause a bounce on the graph. And we'll talk about that in a second. Solving for x, add 9 to both sides, x equals 9. Solving for x, add 3 to both sides, x equals 3. Add 3 to both sides, x equals 3. Well, these are the exact same root. So you bounce on graph. We will talk about that later on in these notes to figure out what it means to bounce on the graph. All right, let's move on down to our second part of our notes. Given the polynomial in factored form, find all roots, sketch a graph using your end behavior, your exact roots, and then approximate the maximum minimum. If I'm finding my roots, I need to set each of my factors equal to 0. X minus 1 equals 0. X plus 1 equals 0. X minus 2 equals 0. Add 1 to both sides. My first root is x equals 1. My next factor, in order to isolate x, I'm going to subtract 1 from both sides, so I get x equals negative 1. My third factor, to isolate x, I'm going to get x equals 2. I found all my roots. Boom. And then sketch using end behavior. If you don't remember this, let's write it down. To find your end behavior, you have to figure out what is the degree. Is it even or odd? And then you have to figure out what is the leading coefficient. Is it positive or negative? Well, right here we've got how many degrees? Well, we don't know because it's not in standard form, so we can count our x's. 1, 2, 3. Degree of 3, which means odd. And my leading coefficient, well, this is a positive function, so it is positive. If I'm odd positive, think about our dance that we do. Odd positive is going to look like this, which means my graph is going to start down here, and it's going to end up here. Pull out those notes. How do we write end behavior? As x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. As my function is going to infinity on the x, my function is going to infinity. As we travel negative infinity on the x, the function is going down to negative infinity. Exact roots, we already did those, and we'll approximate the maximum on the graph. Plot your roots before you can do anything. So I have 1, negative 1, and 2. Remember, I'm starting down here, so I'm going to go up, turn around and come back down, turn around and go back up. Later on this unit, we will talk about how to approximate where our max and mins are, and so we can have a better sketched graph. All right, last example, and then I'll see you in class. Given the following polynomial in factored form, let's find the roots first. Well, x minus 1 squared, remember this gives me a bounce. So this is really saying x minus 1 equals 0 and x minus 1 equals 0, because this told me x minus 1 times x minus 1 because of that squared. So this was split off into both of those. And then you've got x minus 2 equals 0, x minus 5 equals 0. You're going to add 1 to both sides. So x equals 1. Add 1 again to both sides just in order to isolate that x. Well, these are the same. So you bounce. Let's go ahead and plot that on the graph so we don't forget. Go over to your graph, plot that point, and put a B right there, just so you can remember you're bouncing. What bouncing means is you're going to go up and hit it, and then go right back down. Or if you're starting from the top, you're going to go up from the top, go down, hit it, and bounce right back up. Okay. And then let's finish solving for our roots. Add 2 to both sides, x equals 2. Add 5 to both sides, x equals 5. Boom, we found all our roots. Find our end behavior now. Well, what's our degree? Well, we have x squared, which tells me I have 2 x's. So 2 x's, my third x, my fourth x. My degree is 4, which means I am even. My leading coefficient, what's my leading coefficient? Am I positive or negative? I am negative. So even negative is going to look like this, meaning we're starting down here and we are ending down here. So what's our end behavior? As x goes to infinity, f of x goes down to negative infinity. As x goes to negative infinity, f of x is going to go to negative infinity. As x goes to infinity, your function is going down to negative infinity. As x goes to negative infinity, your function is going down to negative infinity. We found the exact roots. We'll approximate the maximum as we're working. Plot the rest of our roots. 1 is here, and the last one is here at 5. So if I'm starting down here, I'm going to go up. Remember, we're bouncing, so we don't cross through. We just go right back down. Go up to cross through this one because we're not bouncing. Turn around and cross through this one because we're not bouncing as well. And there's a sketch of our graph.